So 4.2, chords and arcs of circles. So the goal is to solve for x, basically. It's going to be for an unknown variable, which is either x, y, whatever they decide to put there, using things that we know about chords and arcs of circles. So the first thing is we're looking at this line right here. It says any segment with endpoints, so these are endpoints, that are the center and a point on the circle is a radius. So anything that has two endpoints where one end of it touches the circle and the other end of it touches the center, that's called a radius. So again, you should know that the radius goes from the center of the circle to a point on the circle. It could be here, it could be here, it could be here, it could be anywhere on there. The next thing is a segment that passes through the center of the circle is a diameter, okay, of the circle. Now, it must go all the way through the center of the circle. So it's got to be a segment that goes all the way through the center, all the way to the other side. That would be your diameter, and you see that labeled there. Next, the given point in the middle is called the center. The point names the circle. So if it is, if that point is C, then that is circle C. If that's A, it's circle A. If that's B, it's circle B. Whatever that point is called is the name of the circle. Any segment with endpoints that are on the circle is called a chord. So a diameter is a special type of chord because it has endpoints on both sides of the circle, but the diameter goes through the center. A chord does not have to go through the center. You're going to see some of those today. So a chord could be down here, it could be on the side here, it could be way down here. It just has to have 2 points on the circle. So the chord is more of like what we're going into a little bit later. So those are that's your first kind of section. That's the top half of the chords and arcs of circles. Example 1, it says name the circle, name a radius, name a chord, and a diameter. So in both of these, we're going to want two things. On yours, it has circle, radius, chord, diameter. It kind of cut off on there. So the name of this circle is, and the way you would name this on here, this is called circle. It's kind of weird because it has the dot in it. O. So circle O is the name of the circle. You name it by the middle point. So that's circle O. So is the other one, by the way. They're both circle O. We're looking at the one on the left right now. The radius, I have three options. I could say OC, OD, OE, DO, EO, CO, however you name it. It's either this segment, or this segment. All those are radii, so that would be a radius. So you could use either one. It doesn't matter. We'll say OC. That's a line or a segment, so we put a little line over it. A chord is touches two sides, touches the circle. So one up here, AB, would be a chord. And then the diameter is the one that goes directly through the center of the circle. So we say DE would be a diameter. So that takes care of the first circle. Again, on the second circle, I already told you kind of have the same thing. It is circle O is the name of it. And that's just because of that middle point. Whatever the middle point is, that's what the circle is. The radius is OC or OA or OB. So you have three different options. It could be from C to O, from A to O, from B to O. It's just from the center to a point on the circle. So we'll say OB. A chord is up there, so it's on 2 points of the circle. So again, D to E would be a chord for that one. And then the diameter goes straight through the center all the way across. That would be A to C. And so there we have our names. So that just kind of gets you used to, again, this is review part. That just gets you used to naming the circle. And since a diameter is composed of 2 radii, which would mean the radius times 2, right? So a diameter equals 2 times the radius, and a radius is half of the diameter, or the diameter divided by 2. Again, another thing that's kind of reviewed. The radius is half of the diameter. The diameter is 2 times the radius. That takes us through the first example. 1, 2, 3, and 4. We're just going to kind of read through those things, make sure that they make sense to you, okay? So in Theorem 1, it says within a circle or in congruent circles, chords that are equidistant, so an equal distance from the center or centers are congruent. So for instance, if the distance from O to F and the distance from O to E are the same, then this chord and this chord have to equal each other. So basically, we'll be setting those equal to each other and solving for x in a little bit. We'll be making equations out of that. Okay. Theorem 2 says central angles have congruent arcs. So that means this angle right here, if this angle and this angle are the same, then we know that their arc, that their arcs are the same, the length of their arc. So basically, if the angles are the same, then where the angles go to, which is the arc of the circle, we know that they're the same. In this one, it basically says if we know that these two angles are the same, then we know that their chords are the same. So from A to B, if I made a line like inside of the circle, and from C to D, those are two chords. They would be the same distance from each other. And then lastly, Theorem 4, it says in a circle, if you have congruent chords, so if these two lines are exactly the same, then the arcs are exactly the same. Then this one and this one are equal. So if the chords are the same, the arcs beside them are the same. So basically, these are all ways that we can set things equal to each other. And it's going to help us in the circles to set things equal to each other so that we can solve for x, which is what you're going to want to do in the equations. You're going to want to solve the equation out. So you're going to want to be able to set them equal. So those are 4 ways that we can set the equations equal to each other. So that takes us through page 1. So we'll move to page 2 of the notes, where we actually get an example. Look at the numbers, but it says the following chords are equidistant from the center of the circle. So you can basically see that the center of the circle is at O, right? So it's at O. And they're telling us that this line is 9 and this is 9. So that means that this chord and this chord have to be equal. It also means that this splits this chord in half. So P to Q is 12.5. So what is Q to R? 12.5. So then we can find all the way from P across to R. So this whole line is what? $25. Yeah, so P to Q is 12.5 and Q to R is 12.5. All the way across is 25. So if P to R is 25, then that means R to S also has to be 25. Okay? So they're the same length. So this one is 12.5 and 12.5, so that's 25. the whole way across. And then that one also is 25. So that helps answer your question there. In B, it says solve for x. So we're looking at the length of, x is the length of this chord. You really don't have to solve anything. But if this is 5 from here to here, what is this area here? 5, which means the entire chord is 10. So all the way across from here, all the way across is 10, which means that this chord here also has to be 10. So in this one, in this case, you just get x equals 10. And there's your reason and why. So those are very basic, just starting with the basics here. But you see that those equal each other. And the reason they equal each other is from our theorems that told us that if the lines are the same distance from the center of the circle, which they are, then the chords are going to be equal to each other. So that's kind of what we're looking at here. So now we go to the last three theorems, which are going to be basically the same type of thing. Theorem 5 says, in a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. So that looks a little bit tricky, but here's the diameter. So the diameter is perpendicular to the chord. That means perpendicular means right, it creates a right angle there, so it creates like that 90-degree angle. So if the diameter is perpendicular to the chord, it bisects, it says, the chord. That means it splits the chord in half, which means half of it's here, half of it's here. And it bisects the arc. That means it splits this arc in half. So this is half of it, and this is the other half of it. So basically, again, it means you're being able to set those two things equal to each other. The two halves of the chord and the two arcs, you'll be able to set equal to each other because it's perpendicular there. Okay? Theorem 6 says, in a circle, if a diameter bisects a chord, again, same type of thing as we had up here, that is not the diameter, so this chord is not the diameter, then it is perpendicular to the chord. So all it means is that it creates the 90-degree angles. That's all you have to know there. Number 7. In a circle, the perpendicular bisector of a chord contains the center of the circle. So if you have a chord and you bisect it at 90 degrees, it means that you are going through the center of the circle. You must be able to find the center there. So these three things basically say the same thing. They're just talking about a different part of it. In part 5, they're talking about how it bisects or cuts the chord in half, or the arc and chord in half. In 6, they're talking about how it makes 90-degree angles. And in 7, they're talking about how it goes through the center of the circle. So those are just 3 more theorems to add. So example 3 says, in circle 0 or circle O, CD, so that chord is perpendicular to OE, which is that little line right there. And O to D is 15. So I'm going to fill that in. So from here to here is 15. And C to D all the way across is 24. If C to D is 24, then what is C to E? 12. And E to D is 12, right? So what does it look like we're trying to do here? We're trying to solve for x. We have a triangle now. We thought we were in circles, but we're not. Now we've got a triangle inside of a circle. So what can we use to solve for x? Yeah, so we're back to that. So we're at the Pythagorean theorem with the right triangle. So we have a squared plus b squared equals c squared. C is our hypotenuse, so that's 15 squared. Doesn't matter if you want to call this a or b. We'll say x squared plus 12 squared equals 15 squared. So we're missing one side, one of the legs of the right triangle. So we're going to move the 12 squared over. So x squared equals 15 squared minus 12 squared. So we got to go to the calculator, put in 15 squared minus 12 squared. See what you get. 81. Good. So x squared equals 81, and then we want to take the square root of that.
9.
Yep, that is 9. So x is 9. So 9 is going to be our answer there, and that makes sense. The two legs, remember, have to be shorter than the hypotenuse. So you may have to use the Pythagorean theorem as you go through this. So that is one way of solving some of these questions, especially if it shows you that it sets up like a triangle. And this one shows how it's set up like a triangle there. All right, example 4. Find the value of x to the nearest tenth. So sometimes it's hard to see where they're at, but x is right here, so that's that line. This whole diameter is 20, so what is this part of the triangle? 10. This part is 10. And then if this whole chord is 16, then this part is what? 8. So there is our right triangle. So we have a squared plus b squared equals c squared. Then we plug it in. X squared plus 8 squared equals 10 squared. We're doing the Pythagorean theorem. We're trying to solve for one of the legs of the triangle. So we're going x squared equals 10 squared minus 8 squared. So x squared equals 36. And the square root of 36 is 6. So x is 6. That's our missing side there. All right? So you have to remember there to put those in half. Now, on the you try, let's explain kind of what's going on here. So, in this problem, you have this right angle. You basically have to, in this one, you have to create a triangle. So let's that's not good. Let's try again. There we go. All right. So that triangle is a radius because it's going from the center to a point on the circle. This is also a radius from the center to a point on the circle. So we could call this x also because they're going to be the same, right? This side of the triangle is 3.6. What is this side right here of the triangle? 4. So we have two sides of the triangle. We got to solve for the hypotenuse. So we're going to do a squared plus b squared equals c squared. If you look here on this one, you have the hypotenuse is 12, and you have 6, and you're trying to solve for this part right here. But when you get that answer to find what x is the whole way across. So you want to take that answer and multiply it by 2 after you get your answer to figure out all the way across. All right, so I'm going to give you just a couple minutes to try those two to solve them. On the U-try, so the first one, you did 3.6 squared plus 4 squared equals x squared. So because we had a squared plus b squared equals c squared. So what did x end up being at the end? If you round it to one decimal place, maybe? Yeah, 5.4. So x equals 5.4. When you do 3.6 squared plus 4 squared, you should get like 28.96. And then you take the square root of that to get x. Now, in b, you have, so if you think about it, you have 6, we could call this y if you want to. We'll call it y. So you have 6 squared plus y squared equals 12 squared. And so it's kind of the same thing we were doing. We're trying to solve for one of the legs of the triangle. So we had 12 squared minus 6 squared, which is 108. And then we took the square root of 108 to one decimal place. So that's what, 10.4. So 10.4 is that part, but we want the whole length to solve for x. So this part is 10.4, so that means this over here is 10.4. So x is going to equal what? 20.8 all the way across. So the whole chord. Because we want all the way across. So we found that part of the triangle, which is half of that chord, but we want it to be all the way across there. So it's going to be 20.8. So you may have to do, like I said, you may have to do a little bit of solving for a side of the triangle using the Pythagorean theorem. You may have to be cutting it in half or multiplying by 2 to get all the way across the chord. You may just have to set the two chords equal to each other if you don't have, if it's not asking for the Pythagorean theorem. So those are kind of the questions that can go with the section 2 chords and arcs. So let me take you to the assignment. Pythagorean theorem problems. X is all the way across the line. You want to find that part of the triangle, and then you'd have to multiply by 2 to get x. Here, you already have the hypotenuse and that leg of the triangle. You just got to find the other leg. Here, you have the hypotenuse. You have this whole side, so you have to figure out what this part is, and then you have to find x. So you'll have this part, the hypotenuse. You'll have to solve for x. So those are your questions that you go through. In number 5, the only one that I thought could be a little tricky, this arc, this angle, this arc here is 114 degrees, right? All the way around a circle is how far? 360. So these two here, these are two chords. That means that this and this have to be the same. So I could take 360 and I could subtract out the 114. I could figure out how much is left, and I should be able to just divide it by 2 to get into both of those arcs because they're both going to be equal to each other. Okay, so that is the only question I thought might be a little bit tricky on there as you get through. Questions for section 2. You answer all those. You can go and answer them today, and then if you miss one, you can ask me if you need any help on it, and then you can go back a second time to get it right. All right, so that is your work for today. Yes.
I want to go take it on my phone and